predator becomes prey in the Florida Everglades as hundreds of hunters descend on the sun.
Burmese pythons have devastated native wildlife in the Everglades.
6 weeks of footage, 37 cameras, 12 miles of South Florida wetland. Dr. Michael Kirkland had positioned the trail cameras across the Big Cypress National Preserve for a purpose that was, by scientific standards, unremarkable. Document Burmese python activity, map their corridors, build a cleaner picture of what the invasion was doing to the underlying food web, standard survey work, the kind of thing his team had done dozens of times before. When he pulled the memory card at the end of the monitoring period and drove back to the field station, he was expecting data, numbers to feed into models, footage of pythons moving through corridors at specific times of night, maybe some supporting documentation of the silence that every researcher working in these ecosystems had started to describe, the eerie, structural absence where the sounds of a functioning subtropical wetland used to be. He loaded the card that evening and worked through the footage methodically until he reached one particular sequence, 20 seconds of video from a camera mounted on a cypress trunk deep in the preserve. He watched it once. Then he picked up his phone and called every member of his team. Not tomorrow, that night. What the camera had captured was not a python. It was not any of the species the survey had been designed to document. And the implications of what appeared in that 20-second window stretched well beyond anything a single researcher could interpret in isolation. Before we get to what Kirkland actually saw on that memory card, we need to go back. Because what made that footage significant is 30 years of context that most people have never fully understood, and once you understand it, that 20-second clip hits completely differently. Think about this. When was the last time you heard something described as genuinely unexpected in a scientific study? What Kirkland witnessed that night was exactly that. Stay with us. How a Paradise Became a Killing Field, August 24, 1992. Hurricane Andrew made landfall on the southern tip of Florida, carrying sustained winds of 165 miles per hour. 65 people died. $27 billion in property damage was recorded across the region. Among the structures the storm demolished was a reptile breeding facility south of Miami that housed a significant captive population of Burmese pythons. The enclosures didn't hold. An unknown number of large tropical constrictors slipped out into the flooded landscape and vanished into the water and the sawgrass. In the chaos of a Category 5 aftermath, escaped snakes were not a priority. Nobody organized a search. That release was one piece of a larger pattern already in motion. Across the 1980s and into the 1990s, tens of thousands of South Florida residents had purchased Burmese pythons as exotic pets. They were sold as hatchlings, roughly the diameter of a finger. Within 3 to 4 years, they were 12 feet long and required space measured in rooms rather than tanks. When owners finally confronted that reality, a predictable percentage of them drove to the edge of the Everglades and released the animal. They told themselves it was the humane decision. In biological terms, it was the introduction of an ambush predator into an ecosystem that had no prepared response to one. The Everglades, covering more than 1.5 million acres of subtropical wetland, offered a Burmese python everything its native range in Southeast Asia had provided and more. Year-round warmth, permanent water, a food supply so abundant and so unprepared for a large constrictor that the ecosystem functioned, from the python's operational perspective, as an open buffet with no closing time. The native wildlife had spent thousands of years co-evolving with the actual predators of the region: alligators, bobcats, Florida panthers. A Burmese python represented a completely different category of threat. An animal that could reach 15 feet, sense body heat in total darkness through infrared-sensitive pit organs along its jaw, lie perfectly motionless in 2 inches of water for hours, and strike at a speed faster than a raccoon's nervous system could track. The raccoon would walk past a coiled python the way an ordinary person walks past a garden hose. There was simply no behavioral script for it. Dr. Frank Mazzotti, a wildlife ecologist at the University of Florida and one of the founding researchers of the modern python response effort, described the introduction in terms that other researchers have repeated consistently. Releasing Burmese pythons into the Everglades, he said, was like releasing wolves into a petting zoo. A female Burmese python lays between 50 and 100 eggs per clutch, and incubates them with a sustained thermal commitment, more characteristic of birds than of reptiles, coiling around the clutch and shivering to elevate the internal temperature above the ambient environment. No native predator in South Florida had evolved any strategy for engaging either the adults or the nests. The population trajectory went vertical. Current conservative estimates place the Burmese python population in South Florida at approximately 100,000 animals. Higher-end estimates from research groups working in the Western Everglades reach 300,000. 300,000 apex predators in an ecosystem that had none of them 2 decades earlier. Mazzoti's landmark 2012 study in the Proceedings of the National Academy of Sciences documented what the invasion had done to the native mammal community. Raccoons in the most heavily affected zones had declined by 99.3%, opossums by 98.9%, bobcats by 87%. These were not reductions. They were structural collapses at the population level. The numbers are not the most disturbing part of the record. The most disturbing part is what Mazzotti describes when he drives roads through the Everglades that he drove for 3 decades before the invasion. Roads where in the 1980s, a vehicle could not travel 100 yards after dark without slowing for an animal crossing. Now his team drives for miles and finds nothing. No movement in the headlights, no sound from the sawgrass, only the engine and a silence that a functioning subtropical wetland is not supposed to produce. Does that kind of silence have a weight to it? According to every researcher who has spent time in these ecosystems, the answer is yes. And it is unlike any silence that belongs here. The removal problem no one solved. Florida's official response began with the Florida Python Challenge, a public hunting competition run by the Florida Fish and Wildlife Conservation Commission. In its 2024 version, participants removed 195 Burmese pythons across a 10-day event. If the true statewide population is 300,000 animals, that removal number represents approximately 0.065% of the total. A single breeding aggregation could replace every snake the challenge removed before the next event was even announced. It was not a solution. In no statistical sense was it even a dent. The state moved to professional contract work. Full-time hunters were employed under multi-year contracts to cover specific zones of the Everglades under the joint administration of the South Florida Water Management District and Florida Fish and Wildlife programs. Donna Khalil, the first female contract hunter in the program, became one of the most publicly recognized voices in the effort. She has described the work in terms that communicate what the invasion has done to the environment that surrounds it. Hunting Burmese pythons at night in the Everglades, in her framing, is like hunting ghosts. The headlamp sweeps the edge of a canal for hours and finds nothing, nothing, nothing. Then something registers at the far edge of visibility, a shadow that does not match the surrounding vegetation, and it resolves into a body the diameter of a telephone pole, coiled so completely motionless that until it moves, it resembles an exposed root system. Since the contractor program launched in 2017, professional hunters have removed more than 23,000 Burmese pythons from Florida, 23,000 animals. And based on working population estimates, that removal figure still represents less than 5% of the total. The population continuously replenishes faster than any removal program can draw it down. Every technological approach attempted has encountered the same fundamental constraint. Thermal imaging drones work reliably on warm-blooded targets. They cannot distinguish cold-blooded constrictors from the surrounding environment because the snakes closely match ambient temperature. Robotic prey decoys are simply ignored. A Burmese python is an ambush predator. It waits for genuine prey to arrive and shows no particular interest in mechanical substitutes. The one approach that has produced sustained results is the Judas Snake Program, developed by Ian Bartosek of the Conservancy of Southwest Florida. Researchers surgically implant a GPS tracker in a sexually mature male python, release him, and follow his movement through breeding season directly to a breeding aggregation of multiple females. Bartosek's team has used this technique to locate and remove some of the largest breeding females on record, including individuals weighing over 200 pounds. The Judas program produces the highest removal rate per hour of any current technique. It is still not closing the gap, and experienced hunters have started saying something the state agencies have been slow to formally acknowledge. Mike Kimmel, a Florida contractor known publicly as Python Cowboy, has said in multiple interviews that the animals appear to be learning. The snakes are progressively withdrawing into deep sawgrass and cypress hammock zones where sustained human presence has never been established. Breeding populations are concentrating in the areas that are hardest to reach. They are adapting to removal pressure faster than the removal pressure is adapting to them. Here is a question worth sitting with. If a predator species begins modifying its behavior in direct response to human hunting patterns, what does that tell us about the trajectory of a removal program that depends on those patterns staying consistent? Leave your thoughts below. The invisible threat nobody saw coming. The discovery that fundamentally reframed the entire response effort did not concern the Burmese pythons at all. It concerned something the pythons had brought with them that nobody in the early years of the invasion had thought to look for. Dr. Terence Farrell, a herpetologist at Stetson University, was conducting routine health screenings on wild-caught animals when he noticed a consistent pattern of illness in the native snake community, not in the pythons. In the natives, garter snakes, pygmy rattlesnakes, eastern diamondbacks, all appearing in his samples emaciated, lethargic, with mouths hanging open, and visible respiratory distress. Necropsy results were consistent and severe. The lungs of affected native snakes were packed with dozens of small, pale, translucent organisms, visibly alive and motile, tangled in dense masses inside respiratory passages of animals that were slowly suffocating. In animals examined while still alive, the organisms could be observed extruding from mouths too weak to close. The organism was identified as Railietiella orientalis, the snake lungworm, a pentastome parasite native to Southeast Asia. It had arrived in Florida inside the Burmese pythons. The parasite and the python share millions of years of coevolutionary history. In their shared native range, the python's immune system manages the parasite load without producing serious clinical effects. The python functions as a carrier. It hosts the parasite, transmits the parasite, and does not die from the parasite. Florida's native snakes had never encountered it. Their immune systems had no evolved template for responding to it. Farrell has described the dynamic using the same historical comparison that makes the mechanism immediately legible. First contact between European explorers and isolated populations with no prior exposure to the diseases those explorers carried. One group had developed partial resistance over centuries of exposure. The other had none. The transmission pathway makes containment through any single intervention effectively impossible. An infected python deposits waste containing microscopic lungworm larvae. Cockroaches, abundant throughout the Everglades ecosystem, consume the waste and ingest the larvae. A native frog eats an infected cockroach. A native snake eats the frog. Nothing in this chain is aberrant. This is how the wetland food web has always operated. Except now, every frog in the chain is potentially carrying a lethal infection for the next snake that eats it, and the snake has no mechanism for detecting that before it is already committed. Dr. Melissa Miller, a University of Florida research parasitologist who has worked extensively on the outbreak, established the full geographic and taxonomic scope of the spread. A minimum of 18 distinct native snake species have been confirmed infected. The geographic distribution of the parasite now extends as far north as Jacksonville, more than 300 miles from the original introduction zone. Then Miller's team confirmed the finding that changed everything about the strategic framework of the response. The lungworm no longer requires the Burmese python. It has established a self-sustaining transmission cycle that operates entirely through the native snake community, without any python involvement. Even if every single Burmese python in Florida could be removed overnight, the lungworm would remain. It is now in the cockroaches. It is in the frogs. It is in the native snakes. It is cycling through the ecosystem on its own terms. Florida is now fighting two simultaneous invasion fronts. The pythons are collapsing the mammal community from the top of the food web down. The lungworm is dismantling the native reptile community from the bottom up. The Everglades is being demolished from the roofline and the foundation at the same time. There is one anomaly buried inside the outbreak data that has captured the attention of every researcher working on the problem. The Florida cottonmouth appears to be substantially resistant to the lungworm. Farrell's team examined cottonmouths from areas of confirmed heavy infection and found parasite loads so low as to be functionally insignificant in a species that should, by every predictive model, be devastated. Nobody has yet identified the biological mechanism that produces the resistance. But somewhere in the immunology of that one resistant species, there may be information that could eventually be used to protect the others. That single anomaly may be the most important loose thread in the entire response effort right now. The Emperor returns. When the Florida Fish and Wildlife Conservation Commission announced that it was deliberately releasing hundreds of large snakes into the wild in northern Florida, the surrounding communities reacted with immediate and vocal outrage. The announcement had traveled faster than its context. The people who were angry had not read past the first sentence. The snake being released was the eastern indigo, not an invader. The exact opposite. Drymarchon cooperi, the eastern indigo snake, is the longest native snake in North America. Its scales are so deeply black that they refract into blue-green iridescence in direct sunlight. The word that researchers and wildlife photographers reach for most consistently when they describe an encounter with one in the field is not impressive, not striking, beautiful. But the ecological significance of the eastern indigo has nothing to do with its appearance. It has to do with what it eats. The eastern indigo is an ophiophage, a snake eater. It is completely immune to the venom of every pit viper native to North America. Rattlesnakes, cottonmouths, copperheads. The indigo overpowers them with jaw strength and body mass and swallows them head first while they are still moving. Dr. Dirk Stevenson of the Orion Society, who has led the primary eastern indigo restoration effort for more than 2 decades, calls the species the emperor of the forest floor. At ground level in an intact southeastern forest, an adult eastern indigo has no functional challenger. The species regularly reaches 8 feet in length. Individuals over 9 feet have been documented, but the emperor had been absent from the northern portion of its historical range for more than 50 years. The eastern indigo depends on gopher tortoise burrows for shelter through winter months, when surface conditions become too cold for a large tropical lineage snake to remain active. As development across Florida progressively eliminated the longleaf pine habitat that gopher tortoises require, the tortoises vanished from large portions of their range, and the indigos went with them. By the 1970s, they were functionally gone from northern Florida. The Orion Society initiated a long-term captive breeding program in the early 2000s and spent more than a decade reconstructing longleaf pine ecosystems in the Florida Panhandle before the first animals were released. The restoration was not simply a matter of introducing snakes into available habitat. It required rebuilding the full community of species that a functioning longleaf flatwood needs to operate. The understory grasses, the fire regime that longleaf pine depends on, and the gopher tortoise colonies that would eventually provide the burrow networks the indigos require for winter survival. When the habitat framework was finally ready, captive-bred eastern indigos were released into the Apalachicola Bluffs and Ravines Preserve in the Florida Panhandle. Then, in late 2023, a trail camera positioned at the entrance to a gopher tortoise burrow in the preserve captured footage that Dr. Stevenson watched 11 times before he allowed himself to accept what he was seeing. 2 eastern indigo hatchlings, not released animals. Hatchlings conceived in the wild, born in the wild, moving through the frame with the unhurried ease of animals that have no reasonable predators in the environment they had just entered. For the first time in more than 50 years, eastern indigo snakes were reproducing autonomously in the wild in northern Florida. The emperor was not merely returning. The emperor was rebuilding its dynasty. What do you think happens when a species that has been absent for half a century reestablishes itself in an ecosystem that changed dramatically while it was gone? That question is about to get a real-world answer, and the answer is moving south. What Kirkland saw on the memory card returned now to Dr. Kirkland's trail camera in the Big Cypress National Preserve. 6 weeks of footage, 37 cameras. The monitoring period that was supposed to produce standard survey data about python activity and corridor usage. What the camera mounted on the cypress trunk had captured was a bobcat, 25 pounds, dragging the decapitated body of a 50-pound Burmese python through the mud toward the tree line. The python's head had been targeted first, neutralized, the rest of the snake killed after. The bobcat was claiming the carcass. For 20 years, the Burmese python had existed in the South Florida ecosystem as an apex predator with no serious challengers. Not because the native predators were incapable of taking one in principle. Alligators are physically capable. Bobcats are physically capable. Florida panthers are certainly physically capable. The barrier was behavioral. The native predators had no learned experience with the animal. They did not recognize it as prey. That was changing. Alligators had been documented across the previous 3 years ambushing smaller pythons in shallow water. Trail cameras from Everglades National Park had recorded a Florida panther, one of fewer than 200 individuals remaining in the wild, stalking a python for 20 continuous minutes through a palmetto thicket before making a killing strike. A python in cooler winter temperatures is metabolically suppressed and slower to respond. Its head is proportionally vulnerable to a predator fast enough to end the encounter before the constricting coils can be brought into play. For the first time in 20 years, the pythons were taking losses. The Everglades was not recovering, but it was no longer being unilaterally consumed. The native predator community was learning to recognize the invader as prey, and the eastern indigo snakes were moving south. The captive bred population released in northern Florida had begun reproducing autonomously. The natural range extension for a successful indigo population is southward. A juvenile Burmese python, 3 or 4 feet long, falls within the size range that an adult eastern indigo could reasonably overpower and consume. For a small python, the encounter almost certainly favors the indigo. A mature 15-foot female Burmese python weighing 150 to 200 pounds is a fundamentally different equation. Dr. Stevenson, when asked about the potential encounter between adult indigos and large adult pythons, has given the same consistent answer across multiple interviews. He does not know. Nobody knows. The encounter has not yet been observed in the wild, but there is a genuine biological possibility that the eastern indigo could, over time, exert meaningful predation pressure on the juvenile Burmese python population in the ecosystems where the two species eventually overlap. Every juvenile python that does not survive to breeding age represents a reproductive failure for the invasion. The indigo may not defeat the pythons. It may substantially slow what is currently an unchecked reproductive cycle. And then there is the question that Dr. Farrell has said on multiple occasions is the one that concerns him most. Not the pythons. The lungworm. Can Raelietiella orientalis infect the eastern indigo snake? The eastern indigo's immunity to pit viper venom is highly specific. It is tied to particular molecular features of the indigo's blood chemistry that neutralize the specific enzymes present in pit viper venom. There is no scientific basis for assuming that the same immunity extends to a parasitic nematode with a completely different biological profile. If the lungworm reaches eastern indigo populations before the indigos achieve self-sustaining densities across the recovery zones, the parasite could functionally eliminate the emperor before the emperor has the opportunity to accomplish what the entire response effort needs it to accomplish. The lungworm could kill the restoration before the restoration has a chance to matter. This is the central unresolved question, hanging over the most hopeful development in the Everglades response effort in 2 decades, and nobody working on it has an answer yet. Where things stand. Dr. Kirkland has kept a personal copy of the trail camera memory card from that monitoring period. He has said in one interview that on the nights when the work feels particularly heavy, he sometimes works through the full 6 weeks of compressed footage in a single sitting. The long stretches of darkness. The game trail between the 2 shallow water channels with nothing moving through it for hours at a time. The structural silence that Mazzotti had described from the roads, captured here in visual form, unmoving and unbothered in the deep interior of the ecosystem where the invasion has done its most thorough work. And then, the 20 seconds. The bobcat, the decapitated python, the carcass being dragged toward the tree line by an animal a third of its weight that had learned something the ecosystem's behavioral library had not previously contained. One moment in 6 weeks when the balance shifted, just visibly, in the direction of the ecosystem the invasion had been dismantling. What began as a small number of released and escaped constrictors in the early 1990s has become one of the most severe invasive predator crises in modern North American ecological history. Across 3 decades, Burmese pythons have spread throughout the Everglades and established themselves in an environment structurally optimized for their survival, their reproduction, and their concealment. In the most heavily affected zones, native mammal populations have collapsed by more than 90%, converting previously vibrant wetlands into landscapes defined by a silence that carries the specific weight of functional ecological loss. The pythons are only part of the problem. The lungworm has established its own independent transmission cycle through the native snake community. Professional hunters have removed more than 23,000 pythons since 2017, and the population has absorbed that removal without measurable reduction. The Judas Snake Program continues to locate breeding aggregations. The Eastern Indigo Restoration is producing wild-born hatchlings for the first time in 50 years. Native predators are beginning to engage the pythons in ways no working ecological model had predicted. The outcome remains genuinely uncertain. The battle is not close to over. Every tool currently in use is making progress that is meaningful at the level of individual encounters and inadequate at the level of the population as a whole. On Kirkland's memory card, in the sequence he returns to on the difficult nights, the ecosystem is doing something it had not been documented doing in a generation. It is pushing back. It is not a recovery. It is not, in the working framework of anyone on his team, anything close to a solution. But it is the first frame of one. What do you think it will take to actually turn this around? Biological control? Technology that doesn't exist yet? Or is the answer already in that 20-second clip, waiting for us to scale it? Tell us what you think, and if you want to follow where this story goes next, make sure you are subscribed. The Everglades has more chapters ahead.